So we need to show that determinant of sigma dot A is same as sigma dot A prime. And if I write U as then I can write the sigma dot A prime as U sigma dot A U dagger, right? Because U dagger would be exponential minus I to sigma dot n. N is any unit vector, so can be 0, 0, 1, which is nothing but the z direction which they have asked us here, right? So this is the first thing that we need to show. So how do we show that? So one of the properties of determinant is this ABS. Since this is just a number, can A, B, C. So if you would like to check determinant of sigma dot A prime, just need to see the determinant of U, determinant of sigma dot A, determinant of U dagger. Right? Okay. So let's first try to see what will be the matrix form of this term. Sigma dot n. So if I want to expand this using this identity, or x is equals to 1 plus x squared by 2 factorial 3 factorial, so on. So I can, instead of I can use identity plus I 5 by 2 sigma dot n plus 5 by 2 sigma dot n square 2 factorial also gets squared and 5 by 2 sigma dot cube 3 factorial and so on. Okay, so let's try to see this term sigma dot n square. Okay, so it will be sigma x nx plus sigma y and full term squared. And read this as this square nx square plus there will be cross terms. So there is sigma x sigma y plus sigma y sigma x and y plus sigma y sigma z plus sigma z sigma y and y z plus sigma z sigma x sigma x sigma z sigma x z. Okay. So we'll use the identity of sigma I square. So if I square any of the polymetrics, I get identity. And another identity is this sigma I sigma j is equals to 2. These are anti-commutators, so they anti-commutators AB plus BA. So this indices if I is equals to j, then this is 1. I is not equals to j, so it's 0. Right? Okay, just let me write it more clearly. It's Dirac delta. So this will be 1 if I is equals to j, 0 if I is not equals to j. So in our case, we have terms like this. So what will, since indices are not same, so all the terms like sigma x, sigma y, sigma x turn out to be 0. So sigma dot n square will become plus x square plus y square plus z square. And since we are taking this to be a unit vector, this will be 1 plus n mod will be 1. Okay. Okay, fine. So since sigma dot n square is 1, what we will have is all the even powers will be 1, and all the odd powers will be basically sigma dot n. Alright, okay. So we can rewrite this exponential here and write it again. The next term will be square of this. So instead of that, I will be just putting I5. There will be a cube. So this will also be squared. That is cube odd terms will give me just this. Then there is 4 power. This will be again just identity, identity, and so on. Okay, so what we can try to merge here is uh, get the identity terms and we'll merge these terms, sigma dot n terms. So there is identity plus the 2 factorial I square will give me minus 1. There is okay, this is okay. There is one I 5 by 2 here. So I 5 by 2 here. So I 5 by 2 here. I square will give me minus 1. And then it will be 5 by 2 square identity plus that is 1 by 4 factorial. This will be plus 1. There is 5 by 2, 4, and so on. And now if we club these terms, sigma dot n, what will we have? Plus 5 by 2 sigma dot n plus 1 by 3 factorial sigma dot n. There is okay, I cube. I cube will give me minus I and okay, 5 by 2 cube and plus I will have I power 5, which will be okay, again I think plus I by I by I factorial sigma dot n by 2 5 and so on. So this looks like cosine, and this looks like sine, because cos x, you know how do we write series? Okay, cos x is 1 minus square by 2 factorial plus 4 by 4 factorial and so on, all the even powers. Then there is sine x, this is x, this is cubed by 3 factorial is power 5 by 5 factorial and so on to give me odd. So what are the x like terms here? These are the 5 by 2, and here we can actually take I, okay, we can take 5 dot n and I outside. So What will we have? We have initial I 2 sigma dot n. It's nothing but cos 2 identity plus I 2 sigma as some sigma. Oh, okay, just can write sigma dot n, right? Okay, so this is the result. Now our goal is to see the determinant of this. Determinant of exponential I 2 sigma dot n. So that will be, okay, say, as asked in the n is a z part. So sigma dot n will be sigma z. Okay, so determinant of exponential I 2 sigma z, and how we are going to write this will be cos phi by 2 identity plus I sin phi by 2 sigma z. Okay. And this cos phi by 2 sigma z is defined as this 0 0 plus 1. Diagonal entries are like this: I sin phi by 2 0 0 cos phi by 2 minus I sin phi by 2. And so one can easily check what is this. This is e power I phi by 2. This is minus phi by 2. And determinant, if we take determinant now, we will have just power I phi by 2 multiplied multiplied by plus I phi by 2 should be 1. And so we take determinant of sigma dot a. We want to prove that this is fully determinant of okay, just e power I phi by 2 sigma dot n, sigma dot a, and then there is again sigma dot minus I phi by 2 sigma dot n, and we know this determinant. Okay, so this is 1 sigma dot determinant of sigma dot a is 1 e prime, let's say. Okay, prime. So nothing changes. We prove this. This is we proved the first part. We were able to show that this determinant is invariant under this kind of transformation. And now we need to find this new terms with respect to the old one. Okay, fine. Okay, so next, first, let us write sigma dot A. So it is sigma x, x, sigma y, easy. And then there is different set, and we need to find the prime and unprimed relation. So for that, how this sigma dot A prime is defined. So there is U, there is sigma dot A, which is U tag, where U is our exponential I 5 by 2 sigma z. Okay. So we will have terms like U sigma x ax u dagger plus U sigma x. And so we need to find these terms. Okay, fine. So how do we find these terms? Okay, first let us try to see u sigma x u dagger. So if I expand this, plus 2, so identity plus I sin by 2 sigma z plus sigma x. This is also multiplied by I by 2 sigma z. Okay, so I multiply the sigma x inside, plus 5 by 2 sigma x plus I sin 5 by 2 sigma x sigma z. Be careful about this order. At first it is sigma x and then there is sigma z. Okay, so okay, so we can make use of another identity here as well to reduce number of matrices. Sigma x sigma z is equals to I sigma y. Is it correct or not? X to y to z, right? If I do x z, I should get y, but there will be a negative sign. Okay, so I can change here x z with negative I. So will I have q sigma x u dagger cos pi by 2 tan t plus I sin pi by 2 z plus cos pi by 2 sigma x. There is negative I and there is another negative I, so that will give me square minus 1, it will give me minus 1 sin pi by 2 sigma y. Okay, so now again there is cos square pi by 2, there is minus cos pi by 2 sin pi by 2 sigma y plus I sin by 2 z sigma x plus I sin square 2 sigma z sigma y. Sin square pi by 2. Okay, fine. So we can again use the identity here. Okay, so we can make some changes here again. This zx will give me I sigma y. This zy will give me minus I sigma x. Okay. Okay. I forgot to this cos square 5 by 2 sigma x. Okay. So there is cos square 5 by 2 sigma x. There is minus cos by 2 sigma 5 by 2 sigma y. I square will give me minus 1. So I will have minus right. So another mistake here. So I sin 5 by 2 plus 5 by 2 sigma z sigma x, and this will give me sigma y. So we have cos 5 by 2 sin 5 by 2 y. So negative y will give me minus minus minus. It will be negative sin square 5 by 2 sigma x. Okay. So we can use the formula for cosine. minus sin 5 into this will give me cos 5 sin x sin 5 sigma y. Okay, so this is how this transformation works. Can look for the other one, like u sigma y u dagger. Okay, so okay, yeah, d plus this will give me I sigma x. It's going to be minus 1, it's going to be plus by 2 x cos square by 2 sigma y plus cos 2 sigma x sin 5 by 2 x by 2. Directly writing sigma z sigma y is sigma z sigma y equals to z and y. This is minus x minus x plus I square 5 by 2 sigma zx minus y. So again, there is sigma y, there is sigma y, y square is minus 1, so okay, so yeah, there's one change here. Sigma z, this is plus actually. A mistake here. Sigma y. So this will be positive. Okay. Now we have cos square 5 by 2 minus sin square 5 by 2 sin y plus okay, this 1 by 2 by 2 x twice sigma y plus minus x. Okay, so this is how this part is getting transformed. Can now for u sigma z u dagger. Well, we can anticipate that there will be no change. Why? Because there is sigma z, and in this portion also we have sigma z. Let's just try to see first. Okay, so we know that sigma z square will be 1. There is 1 by 2 sigma z plus sin square 1 by 2 z. So we have sigma z. So these are the transformations. So our interest was how each and every term will get transferred. So we know this x, this is cos phi sigma x minus sin phi sigma y, same thing but with a plus. So our interest was how each of these terms is getting transformed. So, so sigma dot a prime is ax with okay, u sigma x u dagger plus y u sigma y dagger plus z u z u dagger. So we can write like this. Directly writing the result actually. So this is actually like rotation about z axis. And if one would like to find determinant of sigma dot A would come out to be the length of this vector, and this is invariant under this transformation. So what operation we are doing is rotation, and the rotation matrix one can check is given by this. Depends on counterclockwise and clockwise, but this is a rotation matrix, and we are getting something like this here. You can check. Okay, this is the interpretation.